Analytics is the discovery, interpretation, and communication of meaningful patterns in data, especially valuable in areas rich with recorded information. Analytics relies on the simultaneous application of statistics, computer programming, and operations research to quantify performance. Analytics often favors data visualization to communicate insight. Organizations may apply analytics to business data to describe, predict, and improve business performance. Specifically, areas within analytics include predictive analytics, prescriptive analytics, enterprise decision management, retail analytics, store assortment and stock keeping, unit optimization, marketing optimization and marketing mix modeling, web analytics, sales force sizing and optimization, price and promotion modeling, predictive science, credit risk analysis, and fraud analytics. Since analytics can require extensive computation, the algorithms and software used for analytics harness the most current methods in computer science, statistics, and mathematics. Analytics versus analysis. Analytics is multidisciplinary. There is extensive use of mathematics and statistics, the use of descriptive techniques and predictive models to gain valuable knowledge from data. Data analysis. The insights from data are used to recommend action and to guide decision-making rooted in business context. Thus, analytics is not so much concerned with individual analyses or analysis steps, but with the entire methodology. There is a pronounced tendency to use the term analytics in business settings, e.g., text analytics versus the more generic text mining, to emphasize this broader perspective. There is an increasing use of the term advanced analytics, typically used to describe the technical aspects of analytics, especially in the emerging fields such as the use of machine learning techniques like neural networks to do predictive modeling. Examples: marketing optimization. Marketing has evolved from a creative process into a highly data-driven process. Marketing organizations use analytics to determine the outcomes of campaigns or efforts and to guide decisions for investment and consumer targeting. Demographic studies, customer segmentation, conjoint analysis and other techniques allow marketers to use large amounts of consumer purchase, survey and panel data to understand and communicate marketing strategy. Web analytics allows marketers to collect session-level information about interactions on a website using an operation called sessionization. Google Analytics is an example of a popular free analytics tool that marketers use for this purpose. Those interactions provide web analytics information systems with the information necessary to track the referrer, search keywords, identify IP address, and track activities of the visitor. With this information, a marketer can improve marketing campaigns, website creative content, and information architecture. Analysis techniques frequently used in marketing include marketing mix modeling, pricing and promotion analysis, sales force optimization, and customer analytics, e.g., segmentation. Web analytics and optimization of websites and online campaigns now frequently work hand in hand with the more traditional marketing analysis techniques. A focus on digital media has slightly changed the vocabulary so that marketing mix modeling is commonly referred to as attribution modeling in the digital marketing mix modeling context. These tools and techniques support both strategic marketing decisions and more tactical campaign support, in terms of targeting the best potential customer with the optimal message in the most cost-effective medium at the ideal time. Portfolio analytics. A common application of business analytics is portfolio analysis. In this, a bank or lending agency has a collection of accounts of varying value and risk. The accounts may differ by the social status of the holder, the geographical location, its net value, and many other factors. The lender must balance the return on the loan with the risk of default for each loan. The question is then how to evaluate the portfolio as a whole. The least risk loan may be to the very wealthy, but there are a very limited number of wealthy people. On the other hand, there are many poor that can be lent to, but at greater risk. Some balance must be struck that maximizes return and minimizes risk. The analytics solution may combine time series analysis with many other issues in order to make decisions on when to lend money to these different borrower segments, or decisions on the interest rate charged to members of a portfolio segment to cover any losses among members in that segment. Risk analytics. Predictive models in the banking industry are developed to bring certainty across the risk scores for individual customers. Credit scores are built to predict individuals' delinquency behavior and widely used to evaluate the creditworthiness of each applicant. Furthermore, risk analyses are carried out in the scientific world and the insurance industry. It is also extensively used in financial institutions like online payment gateway companies to analyze if a transaction was genuine or fraud. For this purpose they use the transaction history of the customer. This is more commonly used in credit card purchase. When there is a sudden spike in the customer transaction volume, the customer gets a call of confirmation if the transaction was initiated by him/her. This helps in reducing loss due to such circumstances. Digital analytics. Digital analytics is a set of business and technical activities that define, create, collect, verify and transform digital data into reporting, research, analyses, recommendations, optimizations, predictions, and automations. This also includes the SEO, where the keyword search is tracked and the data is used for marketing purposes. Even banner ads and clicks come under digital analytics. All marketing firms rely on digital analytics for the digital marketing assignments, where ROI is important. Security analytics. Security analytics refers to information technology solutions that gather and analyze security events to bring situational awareness and enable IT staff to understand and analyze events that pose the greatest risk. Solutions in this area include security information and event management solutions and user behavior analytics solutions. Software analytics. Software analytics is the process of collecting information about the way a piece of software is used and produced. Challenges. In the industry of commercial analytics software, an emphasis has emerged on solving the challenges of analyzing massive, complex data sets, often when such data is in a constant state of change. Such data sets are commonly referred to as big data, whereas once the problems posed by big data were only found in the scientific community. Today big data is a problem for many businesses that operate transactional systems online and, as a result, amass large volumes of data quickly. The analysis of unstructured data types is another challenge getting attention in the industry. Unstructured data differs from structured data in that its format varies widely and cannot be stored in traditional relational databases without significant effort at data transformation. Sources of unstructured data, such as email, the contents of word processor documents, PDFs, geospatial data, etc., are rapidly becoming a relevant source of business intelligence for businesses, governments and universities. For example, in Britain, the discovery that one company was illegally selling fraudulent doctor's notes in order to assist people in defrauding employers and insurance companies is an opportunity for insurance firms to increase the vigilance of their unstructured data analysis. The McKinsey Global Institute estimates that big data analysis could save the American healthcare system $300 billion per year and the European public sector €250 billion. These challenges are the current inspiration for much of the innovation in modern analytics information systems, giving birth to relatively new machine analysis concepts such as complex event processing, full-text search and analysis, and even new ideas in presentation. One such innovation is the introduction of grid-like architecture in machine analysis, allowing increases in the speed of massively parallel processing by distributing the workload to many computers, all with equal access to the complete dataset. Analytics is increasingly used in education, particularly at the district and government office levels. However, the complexity of student performance measures presents challenges when educators try to understand and use analytics to discern patterns in student performance, predict graduation likelihood, improve chances of student success, etc. For example, in a study involving districts known for strong data use, 48% of teachers had difficulty posing questions prompted by data, 36% did not comprehend given data, and 52% incorrectly interpreted data. To combat this, some analytics tools for educators adhere to an over-the-counter data format to improve educators' understanding and use of the analytics being displayed. One more emerging challenge is dynamic regulatory needs. For example, in the banking industry, Basel III and future capital adequacy needs are likely to make even smaller banks adopt internal risk models. In such cases, cloud computing and open source R can help smaller banks to adopt risk analytics and support branch-level monitoring by applying predictive analytics. Risks. The main risk for the people is discrimination, like price discrimination or statistical discrimination. Analytical processes can also result in discriminatory outcomes that may violate anti-discrimination and civil rights laws. There is also the risk that a developer could profit from the ideas or work done by users. Like this example, users could write new ideas in a note-taking app which could then be sent as a custom event, and the developers could profit from those ideas. This can happen because the ownership of content is usually unclear in the law. If a user's identity is not protected, there are more risks. For example, the risk that private information about users is made public on the internet. In the extreme, there is the risk that governments could gather too much private information. Now that the governments are giving themselves more powers to access citizens' information,